It is June 8th, 2016, and this video is intended to walk through taking a Cougar DC Controller version 1 from Paul Holmes and getting it connected and working. Starting from the left of the control board, we're going to go through all the connections. The throttle is connected to this 2-pin connector. 0 ohms is stopped and 5,000 ohms or 5K ohms is full throttle. The controller will do nothing if the throttle is connected wrong. It must see 0, and the plug only goes in one way. Black is connected to one side of the throttle, and white is connected to the wiper or the middle port. Second one, next connection to the left is J4, the 24 volt power. Black wire on this one is 0 volts and red is 24 volts. So the connectors are female spade connectors, so the DC to DC converter will have male spade connectors coming out of it. So let's take a look at the DC to DC converter here. The input is from a 12 volt battery. It uses a mini breaker that limits the current to 5 amps, which is much higher than it will actually use. I use the mini breaker as sort of an on-off switch. On the left terminals, green is 0 volts from the battery, and yellow is 12 volts from the battery. On the right terminals, black is 0 volts coming out of the DC to DC converter, and white is 24 volts coming out of the converter. So black on V minus coming out of the controller goes to black on the Cougar DC controller board, and white on V plus goes to red on the Cougar DC controller board. Next connector to the right is J5. This is the pre-charge contactor control. The red goes to the red wire on the contactor, and the black goes to the black wire on the contactor. This one actually supplies power to the contactor, so it turns it on. You don't need another battery connection. The contactor shown is a Gigavac. That is a 6.7 ohm pre-charge resistor that is in series with it. This contactor connects the positive battery pack to a resistor and then onto the B plus terminal on the Cougar DC controller. Next to the right is J6, which is the main contactor control. Red goes again to the red wire on the contactor. Black goes to the black wire on the contactor. Again, this one supplies power, so you don't need any other connections to the battery. The contactor that I'm showing here in the picture is the same type of Gigavac. This contactor connects the positive battery pack to the B plus on the Cougar controller, so it doesn't go through a resistor on this one. And the last connector we're going to deal with on the Cougar DC controller board is a 3-pin polarized connector near U8 and R18, and it is for the serial interface. It does have a label, but the label is kind of covered partially by the connector, so I can't really read it. The connector that is on the board is polarized, so you can't plug it in backwards, but I didn't have a polarized connector to plug into it, so I'm using a non-polarized. But the wiring order is white, red, and black from left to right, and it plugs in as you see in the picture. And on this side of the DB9, you will see pins 2, 3, and 5 on the DB9 serial connector. White goes to 2, red goes to 3, and black goes to 5. The serial connection ends up at a USB to serial converter connected to this old XP laptop running Hyperterminal. The connection settings are 19,200 baud, no parity, 8 data bits, 1 stop bit, and no handshaking. So the B plus terminal was covered with the contactor and pre-charge. The battery pack minus is connected to the Cougar DC Controller B minus, and it's also connected to the motor, which is on the cord side of this grinder. The M+ output of the Cougar DC Controller is 3 wires, which is a little bit weird. We have them all connected together, and then I have that one cable connected to the motor positive, which is on the cord to the side grinder. The wiring of the battery pack is positive on one battery to negative on the other battery with a fuse between. It's a large 300 amp fuse. Powering up just the 12 volt controls, the battery pack's not connected yet, powers up the controller this way. After you hear the pre-charge contactor engage and then turn off, the main turns on, and you should get a power up message from the controller that looks like this. You can check the setup by typing config, and it will show you something pretty close to what you see here. So that's about it for the setup. Turn off the 12 volts, connect the battery pack, and then turn the 12 volts back on. Here we are powering up the controller to get the prompt. Here's the pre-charge, and then you heard the other contactor go. I'm just going to stop the video and take a picture of the screen. Okay, and then I'm just going to type config and then take another picture. Following the circuit as I described it when we're going through the schematics, we start at the positive of the battery pack. We go through this wire to the pre-charge contactor, which has this resistor over here as the pre-charge. Then it comes to this connection, which then goes up into battery plus on the controller. The other connection is to this contactor, which bypasses that resistor and just kind of goes around it. That's the main contactor. The negative starts at the negative of the battery pack, follows along here through this connector into the negative of the controller, B minus, and then this little black alligator clip, it goes down here to one side of my side grinder. The other 3 cables coming out of the controller, these 3 motor cables, are connected together with this bolt, and then alligator clip again takes it into the side grinder. If you take a look at the connector, you see that the alligator clips have their insulation pulled all the way down, and it's only 24 volts anyway, so if these cords were to short circuit, they would fail and kind of vaporize. So we're going to close the mini breaker. That was the pre-charge. That was the main contactor. We've got the Stinky Diaper firmware version 1.0. Things should be going well, so we're just going to give it some throttle. Doesn't go very fast, but that's as fast as it goes, and that sort of gives you an idea on how to connect minimum connections up to the controller, get the contactors hooked up, get a small battery pack hooked up, and run a DC motor, in this case a side grinder. That wraps up the demonstration of what to connect and how it should be connected to make the controller work for you. And that's about it for our demonstration today.